All right, today we're going to talk about the wonderful world of plastics. Plastic is one of the topics that you're going to be required to know about for within topic 4. This is 4.5 specifically. Let's get started here. First off, most plastics are petrochemical based. That is, they're based from oil that comes out of the ground. However, because of the loss of a lot of oil reserves around the world, there has, and environmental concerns, they've been developing new types of plastic that are based on bioplastics, like corn-based plastics and sugar-based plastics. They are being commonly developed. One of those bioplastics that's used is actually one of the 3D print materials. Now, the bioplastics a lot of times can degrade fairly easily when compared to petrochemical-based plastics. So they're not quite on equal footing just yet. International mindedness understand that a big material for plastics is oil. So when you're extracting oil from countries, you have to be aware of the cultural and social situations going around with those countries. They've been used for many years. Plastics are very common nowadays. You probably have more plastics on your person right now than you realize. Now, plastics are covalent bonded materials. They use a covalent bond, and that is where the outer electrons of atoms are close enough to overlap. So they're shared between nuclei, which forms the covalent bonds. All other bonds are ionic and metallic bonds. Now, there are secondary bonds between these molecules as well. If they are molecules of the same substance that are attracted to each other, that's called cohesion. If it's molecules of a different substance attracting to each other, that's called adhesion. Now, plastics are very uniformed in their molecular structure. If it's one type of plastic and it's not like a composite plastic, it's very uniformed. It doesn't, whether it's thermoplastic or thermoset. Now, thermoplastic. What is a thermoplastic? A thermoplastic is a covalently bonded plastic that has weak secondary bonds. Okay, that is, there's long polymer chains in that the plastic is made up by. On a thermoplastic, those chains are very weakly connected together. They're not. It's not a very strong connection. So, as you apply heat, what happens is those secondary bonds break down fairly easily. Any questions so far? Now, deformation in plastic, you can have two different types of deformation. Elastic deformation is where those polymer chains that are coiled, they stretch out and then they'll return back to their original state. So elastic deformation is when something is being deformed temporarily. Plastic deformation usually occurs when there's more force being applied to the material, and that is where it stretches out and the chains slide over each other, and it weakens the material, and it also becomes a permanent change. So elastic deformation is temporary, plastic deformation is permanent. And then you also have to be aware of the role of creep and flow. That is the fact that plastics can become liquid and they can flow out like puddles. Now, the neat thing about thermoplastics, because of those polymer changes, you can melt them back down. So you could stretch them out, you can cut them apart, form them into items, and then melt them down and reform them into different things. As the temperature of a thermoplastic increases, the resistance to creep goes down. In other words, it becomes stretchier. Before it becomes a liquid, it becomes kind of this semi-liquid state that allows it to stretch out. A lot of the 3D printers that we use don't fully melt the plastic. They just use this reduction in the resistance to creep to allow the plastic to be formed. Another name for creep, melting. When any material is undergoing creep, it's basically just melting. For example, ice begins to creep at 32 degrees Fahrenheit. That is the freezing point of water. Tungsten at 6,192 degrees Fahrenheit. So a little bit higher temperature required to melt tungsten. PVC plastics between 212 and 500 degrees. PVC is a broad category of plastic. It's not just one type of plastic. And then for our 3D print materials, PLA, which stands for polylactic acid, that it has a melting point between 180 and 210 degrees. The dyes that are in the plastic actually play a role in that melting point. And then ABS plastic, which is another 3D printing plastic that we can use, and incidentally it's also the plastic that is used to make Legos, has a semi-melting point between 230 and 250 degrees. Now, explain how the reversible effect of temperature on thermoplastic contributes to the ease of recycling thermoplastics. Like I said, because they can be remelted, they're much easier to recycle. That's a typo right there. Because thermoplastics can be remelted, they're much easier to recycle than thermosets, not thermoplastics. Thermoset plastics we're going to talk about in a second. In fact, that you can remelt them makes them one of the easiest materials of anything to recycle. With the exception of metal, plastics are probably the easiest thing to recycle. Metals melt down just as easily. But plastics also melt down. Paper is probably one of the more difficult things to recycle because it needs to be shredded and reprocessed, and that actually takes quite a few chemicals to make that happen. Now, you need to be able to draw and describe the structure and bonding of a thermoset plastic. Whoops. Draw and describe the structure of a thermoset. A thermoset plastic has strong secondary bonds. Primary bonds are covalent bonds, but the secondary bonds between the polymer chains on a thermoset are very strong. They don't break down with heat like a thermoplastic, which means thermosets do not remelt. Okay, if you have a thermoset plastic, you cannot form it and then remelt it. An example of that is Bakelite, which is used in a lot of cookware. It was developed in the 40s, I believe, and was used to create plastic dishes that would not remelt. It's a different type of plastic. Thermoset plastics are typically synthetic materials. They strengthen when heated, but they can't be remolded after they're originally heated. Think about an egg. Okay, an egg, when you crack it open, is liquid. Okay, you can scramble it, you can cook it on a frying pan. Either way, it starts out as liquid. You can't turn it back into a liquid after you cool it. Eggs don't work like that. If you try to do that, you get something that looks like that. Yummy. Now, going back to thermoplastics, you'll notice on the bottom of a lot of thermoplastic materials there is a stamp that has a recycling code. Going down, there's numbers 1 through 7. Okay, you have polyethylene tetraphthalate, high-density polyethylene, polyvinyl chloride, low-density polyethylene, polypropylene, polystyrene, and then other. And other typically is like PLA, which is our 3D print plastic, but also polycarbonate and several other different types of plastics. Nylon is also in that category. Now let's break some of these down. Polypropylene, or as we call it in the United States, polypropylene, and polyethylene thermoplastics. Polypropylene is used because it's fairly strong and has a high resistance to chemicals, grease, oil, and water. Polyethylene is used in several different varieties. You have standard polyethylene and then low density and high density. Low density polyethylene is actually very ductile. Okay, it's very thin and is basically what is used to make saran wrap. So when you think of low density polyethylene, it's like plastic film or plastic wrap. High density polyethylene is used is more rigid, and it is it's gas permeable. Okay, so high density polyethylene allows gas to pass through it. Doesn't allow liquids typically, but allows gas to pass through it. High density polyethylene is used to make like milk jugs and containers for laundry detergent. Those hard plastic containers, those are typically high density polyethylene. There's other plastics that are used less commonly because of environmental or biological reasons. Polyurethanes can be made into foams and coatings. Polyurethane can be are commonly used as cushions in vehicles. In the car, inside the cushions on the car seats, they use typically polyurethane foam. As a coating, as a liquid, it forms a very hard lacquer-like surface sealant that's used a lot of times on woods and metals. And then it can be used, polyurethane is used also to make like skateboard and roller skate wheels. It's kind of a combination of very strong yet also a little bit of pliability to it. Spandex is a polyurethane, so it can be formed into textiles as well. Urea formaldehydes are known for high tensile strength, and they used to be used commonly as insulation, like foam insulation used in homes. But the problem is urea formaldehyde. Any of you guys know anything about formaldehyde? What do you know about it?
It's used for corpses to keep them sort of fresh.
Used for corpses. It's an embalming fluid, if that's what you're bringing up. But it is not a very safe material to be around. So in the 70s, they were concerned that the urea formaldehyde would be leaching formaldehyde gas into environments, so they stopped using that as insulation. Now most commonly you see fiberglass insulation. PVC is another plastic that's really common. PVC the disposal is problematic because it breaks down, and it doesn't break down very well. PVC is pretty much flame resistant. It doesn't melt very easily. If the PVC catches fire, unless it's like exposed to another fuel, it's not going to burn or melt very easily. And also the plasticizers, PVC in its natural state is kind of a goo. It's a liquid at room temperature. It doesn't solidify unless it's mixed with a plasticizer. Now the plasticizers that are commonly used on PVC are pretty toxic. So PVC is not safely used in any food applications, any applications where it could come in contact with food. And whenever you handle or work with PVC, you definitely want to wash your hands frequently. There are other PVCs that are used in plumbing. If you see PVC in the plumbing, typically it's only on the waste lines. Most supply lines in plumbing are going to be either copper, or in newer materials they use something called PEX, which is a plastic supply line, but it's actually made out of polyethylene. PEX stands for polyethylene extrusion. It's pretty strong, and it's kind of like hoses. So have you ever seen copper water lines in your house?
Yeah.
Pardon? Flex line. It's very commonly used, and has been used for 70 years. But PVC typically you're only going to see on waste lines because you don't want to then ingest that water anyway. So any questions? All right, that is plastic.